Hello.
Hello,
Yeah.
sir.
See here. What did I tell you about the Thevenin theorem? See here. This is the load resistor, right? 5 ohms. So
Yeah.
basically, my this is 10 ohms because of this 150 divided by 10 plus RL, right? Now
Mm,
VThevenin. How did I get VThevenin? By removing this the open circuit voltage between them. Now the open circuit voltage between them becomes basically what happens when you remove this. Now so current through an open space would be equal to zero. Because of this current, what is the voltage through this? Voltage is this 10 ohm into the current, right? Now the current flowing is zero. So this becomes zero. So the leftover voltage is only this 150. You can see by applying the KVL also. See here. If you apply the KVL also, you can see here. This is 10. Okay. This is the voltage here is plus minus VOC, which is the open circuit, which is the Thevenin value. Okay. Now if you apply this is 150. Now if you apply this is the current direction, right? This is your I1. This is your I1, but you notice that I1 is what? I1 is 0 because it is open circuit. I1 is equal to 0. Now you apply the KVL, it is entering minus, so minus 150, right? Here plus 10 into I1, right? Again here plus VOC, right? Is equal to 0. But I1 is what? 0 na. So it would be minus 150 plus 10 into 0, 10 into 0 plus VOC is equal to 0. So therefore, VOC value happens to be 150, correct? Which is
mm,
nothing but your VThevenin value. Now, I Thevenin would be equal to, now how to calculate the R Thevenin? R Thevenin is, the procedure is you will remove this, right, in order to calculate. Remove this and short circuit this. So when you are removing this, okay, whichever branch you are seeing and short circuiting this 150, you're just left with 10 ohm, right? 10 ohm. So this I Thevenin would be equal to V Thevenin divided by R Thevenin plus the load RL, right, which you had removed. So again, if you see, this is 150, R Thevenin is 10 and R load is 5. So it would be again 10 amps, which you already got, right? The mistake we were
mm.
doing is that we were not adding this RL here, right? We're not completing the circuit. You're getting my point.
Yeah.
So it is the same thing. Now, sometimes you have to do a problem, okay? A bigger problem in your exam papers, like this type of problem will come, okay? This is plus minus. This is your 24 volts. Okay. This is 10 ohm. Okay. This is 12 ohm. This is okay. I'm recording this. This is 10 ohm. This is 12 ohm. Okay. This is, let's say, 4 ohm. And let's say this is 24 ohm. This is 4 ohm. And this is plus minus. And this is your, okay. This is your 4 I naught, which is the this current. So the current here I naught, this is a dependent current. This is a voltage source which is dependent on current, right? Because 4 into I naught you are doing, right? So basically voltage is equal to resistance into current. Now resistance is a number. So this is a voltage source which is dependent upon current. Okay, this is voltage source which is dependent upon current. Now what it is asking you, use mesh analysis to find the current I naught. Okay, how to
Mm,
find this current? Use mesh analysis, okay, to find I naught. So first of all, you see how many loops are there? Tell me. One is this loop, right? Loop 1, loop 2, correct? And loop 3, right? Hello, are you
mm.
there?
Yes, sir.
Just apply the this thing. So in loop 1, I1 is here. This is your loop 2, I2. This is your loop 3, I3. Okay. So write for loop 1, right KVL for loop 1, right? Now start writing KVL for loop 1. Tell me what would be the KVL. Start from here, right?
Mm,
So this becomes
minus.
Tell, yeah, minus 24. Correct. I'm not here to minus
Yeah.
24. Then here,
Uh, 10
hmm,
I I2 minus,
no,
no,
10.
I1 minus I2
Very good. I1
minus
minus
I2.
I2. Then here this, it will become
12
12.
plus
Uh,
12 I1.
12. I1.
Mm. Then another loop you need to do.
No, not I1. Now see, this is also separating this. This is
Yeah.
separating loop 1 and loop 2. This is separate. 12 is separating loop 1 and loop 3. So it would be whichever loop it is separating. It would be
I1
12 I1
minus.
minus I3. Correct?
Yeah.
Right? I told you na whichever loop. If there was this 12 was here na, then there was not an issue. If 12 was here, then it is not separating. If 12 was here, then I would have written 12 I1. But again, it is separating two loops. So it would be I1 minus I3. Understood?
Mm.
This is the concept. Okay, good. So this you understood. Okay, 12 I1 minus I3 equals to 0, correct?
Mm.
Hmm. If you solve this, so 10 I1, 12 I1, 22 I1, correct? So this will be 22 I1 minus 10 I2 minus 10 I2 minus 12 I3 minus 24 equals to 0, correct? So if you take two common here, it would be 11 I1. You need not to take anything common. You are getting my point. You keep it as it is because we have calculator. Okay. So we will not take something common and all. Just write here. We have calculator now. This is 24. You just write this 22 I1 minus 10 I2 minus 12 I3 as it is. So this is your equation 1. You need three equations to get these values. So this is your
Mm.
equation 1. What about your equation 2? Right now for KVL for loop 2, this type of question is coming in your exam. Na? These type of questions. You just check. I did not take directly that questions. Okay. That questions
Okay.
you will do on your own. Means I will solve for you. Don't worry about that.
Okay.
But you will be able to do. So KVL apply to loop 2 now. Tell me beta.
Yeah.
Now tell me for loop 2 this is the
Uh,
right, this is I2, right? This is I2 and
yeah.
this is and this. Start from here.
10
10.
I2 minus I1.
Very good. 10 I2 minus I1. Then
Uh,
here
plus
uh,
24 I2.
24 I2. Then you see 4 ohm is between which and which? It is separating two loops. So
Yeah.
whichever loop you are taking, that loop current minus the other loop current. That mistake you should not do. You should not write 4 right because now here it is separating loop 2 and loop 3, this 4 ohm. So it
Yeah.
would current would be here
Mm.
4 into
4 into
which loop it
I3.
is in? I2 loop. And
I2.
what loop it is separating? 3 loop. So it
Uh,
would be I2 minus I3, right?
yeah.
Understood?
Yeah.
Like how 12 was here, 12 was I1 minus I3. Now it was separating, right? I1 and I3. So
Yeah.
this 4 is separating I2 and I3. Okay.
And I2. Mm.
Now if you write the same equation for the loop 3 for 4. Suppose now you are taking loop 3, I3 wala loop. So it would be 4 I3 minus I2, right?
Mm.
Now for the loop 3, if you are writing, this is your loop 3, right?
Mm.
Now you start from here. So it would be 12. Okay, right? KVL for loop 3, KVL for loop 3. Tell me what would be the equation for loop 3 here? 12 is separating now loop
Yeah.
3 and loop 1. So what would be the equation? 12 into
12 into
uh,
uh, I3 minus I1.
shabash, very good. Be confident, be bold. Plus, very good. Tell here.
4
Very good, shabash. Come on.
I3 minus I2.
Very good. Yes, this is what I need. Then
Mm.
here,
Plus 4
uh,
rolls.
4 I naught, correct?
Yeah, 4 I naught.
4 I naught. I naught as it is, I'll write I naught, okay?
Yeah.
4 I naught is equal to 0. But can you carefully see what is your I naught actually?
Mm.
If you look at the I naught value, I naught there is, okay,
Mm.
I1 minus I2 is also I, okay. Hmm, okay, 4 I naught. Take. You wrote all these values, correct na?
Yeah.
You check at the node. See, at this node, right? At this node, correct? This
Mm.
current is I1, correct?
Mm.
This it is showing I0 going here, and this is I2, correct?
Mm.
So you can write I1 is equal to I0 plus I2. So therefore, I0 is nothing but I1 minus I2, right? Here
Yeah.
you can see na. Okay. So when you have all these equations, right? So you can substitute this value here, I0 as I1 minus I2, right? For this 4 into, okay, understood? 4 into, instead of I0, you can write 4 into I1 minus I2 here plus 12. This wala value 12 I3 minus I1 plus 4 into I3 minus I2 is equal to 0. 0. I2 is equal to
Mm.
0. For loop this thing, right?
Yeah.
For loop 3, I just substituted this value. So once I substitute this value, I have these values, right? I have these
Yeah.
values. I just open it up. Once I open this, you can open now. Opening is not an issue, right? Getting three
Mm.
equations is 10 standard maths, right?
Yeah.
So first equation that I opened was 22 I1, see, minus 10 I2, right? Minus 10 I2 minus 12 I3 is equal to 24, right?
Mm.
Now second equation is this, right? 10 I2 minus 10 I1, right? Plus 34 I2 plus 24 I2 plus 4 I2, okay, plus 4 I2 minus I3, right here.
Mm.
This also you can open up na.
Yeah.
So this will become 10 I2 plus 24, 34 I2. So it becomes 38 I2, correct?
Mm.
Then minus 10 I1, minus 10 I1, right? 10 I1, I2 and this 4 I2, 14 I2 and 24 I2 becomes 38. Then minus 10 I1 and minus I3. Okay, only this value I have. Minus I I1 and minus, no, minus 4 I3 I have. Minus 10 I1 and minus 4 I3, correct?
Mm.
This value I have equals to 0, right? So I can write this as minus 10 I1, right? Plus 38 I2, 38 I2 minus 4 I3 is equal to 0, right? Hmm? Here also you substitute, see, 4 I1. So I1 value is 4 I1 and
Mm.
which I1 you have minus 12 I1. So it will become minus 8 I1, right? So minus 8 I1. Again
Mm.
minus 4 I2 and minus 4 I2. So it becomes minus 8 I2. 8 I2. Then I3 is there 12 I3 and plus 16 I3. 16 I3 is equal to 0. This is the equation. Now put in the calculator. Okay, mode, go to mode. Okay, equation number of unknowns 3. The first value start with the equation 1. So this is your equation 1. Here, equation 1. This is your equation 2. Okay, this is your equation 3. Equation 3. Just put the value. So the first value is there 30. You make sure that you write in the order, right? You cannot say this is your, actually, this is not your equation 1. This is your first is your equation 1, right? This is 1, this is 2. So 22 I1, 22 minus 10 minus 12, 24. Okay, then this is minus 10, this is 38, this is minus 4, that is 0, then minus 8, this is minus 8, this is 16, this is 0. So get a value of all the values you'll get. So I1 is 2.25. Okay, I1 happens to be I1 is 2.25. Okay, I2 is 0.75. I3 is 1.5. 1.5. So we needed I naught, right? I naught is I1 minus I2. So it is I naught is 2.25 minus 0.75. So just do that. That would be equal to 0.75. That would be equal to 1.5 amps, right?
Mm.
Okay.
Yeah.
Did you understand? Hmm?
Yeah.
Okay. I will explain you one super node concept and then we will see. Like, sorry, super mesh. Okay. Because it's asked na in the exam, 1 mark also they will ask. Okay.
Yeah.
See, when you are having a voltage source like this, okay, this is your plus minus, this is your 20 volts over here, and here you are having 6 ohms, okay, you have 2 ohms, this is your 6 ampere current source, you have 2 ohms here, okay, like this, and 10 ohms and 4 ohms, okay. So here you notice once you have a current source exists, this is a current source, okay, and these are two meshes, right? A loop, these, you see, these are two mesh, actually mesh one. Mesh is a smallest loop, right, which does not contain any other loop. So when you
Yeah.
have basically a current source that is existing between two meshes, right, there is a current source 6 ampere, okay.
Mm.
So in that case we can create a super mesh, okay. Okay, I'll have that. When a current source, okay, exists between two source, exists between two loops, then a common mesh called as super mesh can be formed. Okay. What does that mean? Can we see what we will do here is you are seeing that current source and that 2 ohm resistor is there, right?
Mm.
So these elements only na we will exclude. These things na we need to exclude these elements. Exclude these and elements and form a common node. Okay, like this. This is your plus minus 20 volts. Okay, then this is 6. Across this, so I know I1 is going, and across this I2 is going, correct? So this I will form. So this is your 10 and this is your 4. Okay, 10 ohm and 4 ohm. And I'll have this I1 and across this I'll have I2. Like this I'll apply. Okay, well, how do I apply? See, basically what I rule out here, okay,
Mm.
if you see, okay, here to is not a super mesh, okay. See, here a super mesh basically is arising when two basically meshes have a dependent source. Now here, what is the equation that I am going to write is, for the first part of this, right, I will take I1. So it would be minus 20 plus 6 I1, and for the second part it would be 10 plus 4. What is that? I2, right? Here I2. So it would be 10 I2 plus 4 I2. So is equal to 0. So I'll have 6, this thing 6 I1 plus 14 I2 is equal to 20. Okay. Till here you understood.
Mm.
What else do I have? Can you tell me? If you apply here, correct? Here, KCL. So I1 is equal to what? Hmm? See, current is entering here, reverse direction, right? So, what is the current entering? I1. What else is the current entering to this node? Plus 6. What is the current leaving? I2, correct? So,
Mm.
can't you write I2 is equal to I1 plus 6, right? And you substitute this equation back here for the value of I2. So, it would be 6 I1 plus 14. Instead of I2, you can write I1 plus 6 is equal to 20. So it will become 20 I1, right? 6 I1 plus 14 I1 plus 14 into 6 is 84. 14, 6 is how much? 5 more 3. Yeah. 4. Yeah, 84. 84 is equal to 20, right? So your 20 I1 is equal to minus 24. So I1 would be equal to minus 24 by 20, correct? So that would be equal to minus 24 by 20,
Mm.
not minus 64 it will become, right? 20 64 minus 64 by 20, correct? Minus 64 divided by 20, that will become minus 3.2. Okay. So basically you can always apply a super node between two label nodes. Like for example, super mesh, sorry. See, in this problem, so first thing is that steps I'll mention. This is the step number 1, how to apply super mesh.
Mm.
Okay. Now number 1,
Auto aggression.
see the current source, like the current source, there was the current source, no, this 6 amperes itself, right? And
Mm.
here I1, and here it was I2, right? So this current source itself will give you the now here it gave you I1 plus 6 is equal to I2, right? It gave you a constant equation. So the current source in the super mesh, like in the super node, what happened? See, this was your plus and minus. This was your V2 and V3, right? In the super node, this only, and if I wrote here 5, so it was your V2 minus V3 is equal to 5. So this only gave you the constant. Here also in the super mesh, this current source only will give you the constant equations. Okay. The current source, okay. Are you understanding how was today's class? Did you understand?
Yes,
Huh?
sir.
Uh, see,
Yes.
I am just, see, instead of just solving your problems in the examination, okay, what I'm like in a broader spectrum, I want to develop your concepts so that you can
Mm.
solve any problem. Now you go back there, you should solve with confidence and little
Yeah.
bit practice, okay?
Okay.
Now you understood how KVL and KCL are applied.
Yes,
See,
sir.
electrical engineering is only about how to apply KVL and KCL. If you know the
Mm.
directions, you are getting confused. Y plus, Y minus, sometimes
Yeah.
this, sometimes
But
that. Huh?
yeah. Yeah.
Now everything got cleared.
Yeah.
Yeah, good. Okay, understood now how it is happening.
Yes.
Can you
Mm.
relate physically also? You can relate. Like current will flow from the top to the bottom.
Bottom.
Across the resistor, it would be always positive because across the voltage source, it depends upon the polarity. If it enters the negative, see, it is common, na. See, voltage
Mm.
source is what you are supplying voltage source, right? Right.
Yeah.
So there are two sign conventions. It depends upon us. So if something you are supplying, it is getting minus the,
Mm.
right? See, either you can take the supply, either you can take like this plus minus. If it goes from minus, you can take this as plus. Then you have to take the register wala value minus. Equation remains same. There are two sign conventions. I showed you only one, and you have to apply only one, right?
Mm.
Yeah.
Yeah.
In some books, you will see ulta they are writing. Instead of minus 15, they are writing plus 15. But for resistors, they are writing minus. That is also correct. That is one sign convention. Another is if you are taking this minus, that you take plus. You are getting my point.
Yeah.
Hmm? Okay. Second thing is a super mesh has no current of its own. Okay. So
Mm.
a super mesh will require application of both KVL and KCL. Okay. So you can then withdraw this whole thing, right? And you can
Mm.
form a common mesh, and wherein whichever loop was there, that loop current you can apply. Okay. So we can say that a super mesh has no current of its own. A super mesh has no current of its own. Current of its own. Okay. Once, okay,
Mm.
the elements are excluded. The elements are excluded. Okay. The respective mesh currents. The respective mesh currents. Mesh currents are applied to write the KVL equation. That's it.
Mm.
See here, for example, if I tell you, if I give you a problem like this, okay, let's say this is my 2 ohm, okay, let's say this is 5 amps here, let's say this is 4 ohms, this is 2 ohms, and this is your plus minus 10 volts, this is your 6 ohms here, okay,
Mm.
6 ohms, this is your 2 ohms, 4, 2, okay, this is 4 ohm, this 2 ohm, 10 volts, 4 and between 4 and 2, I connect one 8 ohm resistor. Okay, 2 ohm is there, na? Okay,
Mm.
this 2 ohm, okay, this 2 ohm resistor, okay, I am connecting via 3 I naught. Okay,
Yeah.
see, how many meshes are there? See, one is this I1, correct? One is, another is this I2, another is this I3, correct? Another is this I4, right?
Mm.
Okay, now let me label it, right? So if this is my node 1, correct? So this entire remains node 1. Then this becomes 2, so this is 2, right? Understood now?
Yeah.
This if this is 1, I'm just coloring it. So 1 remains still here, right? If the
Mm.
other one is 2, okay, because potential in a node will remain same. So this part is 2. Understood?
Mm.
2. Okay. This part is your 3. 3. Then this part is your 4, and this is your common reference node,
Mm.
5. Okay, this is the node 5, common node. At this node, if you notice, hmm, where is the super node here now? Can you tell me? This is your homework. Okay,
Mm.
evening we will meet at 5:30. You try,
Mm.
think about this problem. If I explain you, apply your mind, and I'll send you the recording also. Na?
Okay.
Okay, just go through it.